Hello class, so in this video we're going to be going over another technique. This is the fourth one in the series called partial fraction decomposition. Alright, so when to use this is if there's a denominator in the integrand, and if that can be factored. And if it's harder to do without factoring, then that's when you want to factor it, and then make it easier, then yeah, so basically the logic behind it is break a complicated looking rational expression into more manageable pieces. By the way, I'm not going to be going extensively into all the different types of cases and whatnot with this because, I'm an AP teacher, so I'm going to focus on the AP stuff here. If I have time later on, then I'm going to make a more general one, make it a little bit more rigorous, basically. Okay, but anyway, this is the stuff that you'll see on AP most likely, because you won't see every single case, just this. Okay, so let's look at this. If we have this, we can factor that, right? So this is the same thing as the integral of 1 over, that should be x plus 3 times x minus 1. Why did I put a 2? Whoops. Minus 1 dx. Alright, so this, let's say, can be broken up. So what we're claiming then is 1 over x squared plus 2x minus 3 can be broken into something over x plus 3 plus something over x minus 1. What is that? Well, let's figure it out. Let's combine the two fractions here. That'll give us a times x minus 1 plus b times x plus 3 all over this. Alright, and then we get, if you combine that, you'll see that you get ax minus a plus bx plus 3 all divided by this thing, which is the same thing as a plus b all times x plus 3b minus a. Oops, forgot that b, because distributive. All divided by this. So this is equal to, the top is equal to 1. The bottom is equal to itself, right? So since there's no coefficient for x over here, a plus b is equal to 0. Alright, and then negative a, we'll just write it as negative a plus 3b is equal to the constant, which is 1. Okay, we can solve this system of equations. Elimination method, add those together, then we get 4b equals 1, b equals 1 over 4. That means a has to equal negative 1 over 4, right? So we got that, and then we can just plug that in up here and say that our integral is also equal to negative 1/4 over x plus 3 plus 1/4 over x minus 1 dx. I'm going to make this look a little bit nicer. A little bit of barrier there. So integral, I'm going to take the 1/4 out and write it like this. Alright, so we get ln of x minus 1 minus ln of x plus 3 dx, no, not dx, that's already used up, equals 1/4 ln of, so that'll be x minus 1 over x plus 3. Notice that these are in absolute values. Plus c, and this is our solution. Okay, so what do we do when we have limits of integration? Same thing. So let's try that. So this is going to factor into a thing. So that'll be integral from 1 to 2 of 1 over x times x plus 1, right? Okay, so if we're doing that, let's see. 1 over x plus b over x plus 1. Let's see, that's going to equal... I'm just going to do this all kind of quickly, just to make the video not super long. You can also try this on your own and check it if you need to. That's also a good idea. Okay, so there is no x coefficient, so a plus b in this case, yet again, is 0. And then a equals 1. Okay, cool. So that means b equals -1. That's pretty easy. Integral of 1 over x minus 1 over x plus 1 dx. Okay, so we get ln of x minus ln of x plus 1, evaluated from 1 to 2, equals ln of x over x plus 1, absolute value, evaluated from 1 to 2, and we get this, ln of 2/3 minus ln of 1/2. And yeah, that's basically all you can really reduce it to. And let's see. Actually, something interesting looks like it might happen there, so let's just look at the algebra of it. Ln of 2 minus ln of 3 minus ln of 1 minus ln of 2. Okay, so let's see. We got that. So then we get, let's see, we got a plus ln of 2 here, and then ln of 2 there. So we get 2 ln of 2 minus ln of 3. And this is the simplest form that you can get it into. So know your logarithm rules. That'll help significantly. All right, let's try this one now. So similar thing. This is going to factor into x minus 2 times x minus 3. So a over x minus 2 plus b over x minus 3. Let's see what that equals. That'll be a plus b all times x, and then that'll be a -2b and a -3x plus -3a, I mean, all divided by this thing. Okay, this time we do have an x coefficient, so that'll be a plus b equals 1, and then -3a minus 2b equals, in this case, that'll be -4. All right, so I'm going to multiply the whole thing by 2 so that we can get rid of b. So we have 2a minus 3a plus 2b equals 2 over, and then that'll be just the same thing. We didn't do anything to it. All right, so now that 2b is going to be gone. And then we have -a equals -2 if we're just adding these together. That means a equals 2. So what does b equal? Let's see. So a plus b equals 1. So if a equals -2, then b equals 3. Wait, no, that's +2, sorry. So, sorry, 2 plus b equals 1, so b equals -1. All right, cool. So this is the integral from 0 to 1 of, okay, a is 2, so we got 2 over x minus 2 minus 1 over x minus 3 dx. I'm going to make that 3 look a little bit better. Let's see, we're going to get ln of, so actually 2 ln of, 2 ln of x minus 2 minus ln of x minus 3, evaluated all from 0 to 1. Okay, so then let's see, we can make that, we can combine that to one logarithm if we did this. So you can kind of pause the video to get that if you need to. Because I basically moved the power up to here, so that's x minus 2 all squared, and then did the whole division thing. Okay, that'll be interesting. ln of, let's see, that's going to be -1 squared is 1 over -2, and then minus ln of 4 over -3. So we have ln of 1/2 minus ln of 4/3, because we absolute value all that, so it's all positive. Now we have ln of 1 minus ln of 2 minus ln of 4 is 2 squared minus ln of 3 okay, so that's gone. Then we get negative ln of 2 minus 2 ln of 2 plus ln of 3. Alright, so that means we have ln of 3 minus 3 ln of 2 as our solution. Alright. So that's the end of this. It's been kind of longish, but not too long. And yeah, so basically just factor things, try to write them in a way so you can have A and B, get them together, combine them, system of equations, then just plug the thing back into the original with that A and that B, evaluate it, and then it becomes a lot more manageable. Knowing your logarithms also helps a lot, because then you can simplify things to stuff like this. On AP exams, you would probably be given this final answer, and if you're in a multiple choice section, and you wouldn't know that it's this unless you're able to reduce that thing. So learn your logarithm rules, apply them always when you see logarithms, obviously. All right, so that's the end of this. Hopefully it was helpful, and I'll see you in the next video.